Good afternoon. This is Anchor Standard 4 Geometry webinar. It's part of the 2022 Minnesota Standards webinar series on each of the anchor standards. There's 7 anchor standards. All of the resources for these are, if you're watching the recording, linked in the description below. And you can also learn a lot more about all the other anchor standards if you go into that link. So I want to welcome our 2 presenters today. They are phenomenal. We have Vang, who is a teacher in St. Paul Public Schools, and she is also a co-chair of the Standards Committee. And then we have Sarah Moffett, who works with the state Compass math team and supports teachers around the metro area. Also a former colleague of mine in Minneapolis Public Schools and a phenomenal math teacher herself. So I'm going to turn it over to them. I'll stick around at the end if you have any questions. And Sarah, I'll turn it over to you.
I think we'll go with May. Are we going to get started? There we go. So Sarah just did a great job of introducing herself, so I think we can skip ahead.
Yeah. So Sarah and I did work in St. Paul together too, though. So that's
yeah, for 1 year. We had one beautiful year. All right. Okay, so this is part of a series of sessions to introduce and unpack the shifts in the 2022 Minnesota Mathematics Standards. And we are working today on Anchor Standard 4, near and dear to both of our hearts, geometry. So if you have not been to some of the other sessions or seen them on the YouTube channel, we'd like to encourage you to access those other resources in those sessions. And we'll start off with some math. May?
So before I go there, though, because this is a webinar, it's great if you speak into the mic when you are going to volunteer. Or else if you put it in the chat, that's okay too. We'll read it out loud. But that's just something that we want to keep in mind. So we're going to do which one does it belong to start. So if you've not done this before, the blue screen kind of tells you what to do, right? You're going to see 4 images behind this blue box, and your job is to decide which one doesn't belong and have a reason. I know it says put a thumb in your chest. If you have your camera off, that's okay. You can just put a thumbs up on your Zoom screen. That'd be great. And then if you're okay, I'll just call on someone. But if you really want to share, I would encourage you just to unmute yourself. And then if you are online watching this, this will be once you see the images back there, it's a good time to pause and consider the question and what you would say about it. So this one I have to go out of our presentation mode. All right, which one doesn't belong? We'll take a little bit of time. I'll wait for a couple more thumbs up. All right, can we get someone to come off mute? Can you say your name first? And then tell us which one doesn't belong and how do you know?
D, because it has all the angles the same measurement.
That's you, Shelby?
Yep. Oh, sorry, I'm Shelby.
That's okay. You said D because the angles are all the same measurement.
Monica, I would say A because it's the only one without a right angle.
Mary, and I would say C because it's the only one that's kind of on its vertex versus on a side.
Can you explain a little bit more about what vertex means and what you mean by that?
Sure, the point where two sides come together, so it's kind of sitting on a pointy side instead of a flat side.
Beth said C is the only one with no sets of parallel lines in the chat.
Thank you, Sarah.
And Kayla said B. Go ahead, Sandy.
Sorry, I was going to say D because it's the only one that, not D, wait a minute. B because it's the only one that doesn't have any congruent sides.
What do you mean by congruent?
Well, all the others have at least two of the sides are the same measure. And B, if I'm looking at it right, none of the sides have the same measure.
Thank you.
Hey, this is Mike. My son's watching with me, and he said it's probably a trick question that you can probably pick any of them, depending on what you. So I thought he's catching on to this.
Mike, I don't know. Did you teach him anything?
He said no.
Yeah, he's your kid. He's gonna say no. I'm sure many of you have already done which one doesn't belong in your class before. But you heard some of my follow-up questions, right? To when Mary said it's on its vertex, and I asked her to describe a little bit more what vertex meant. Or Sandy had said congruent, and I'm like, can you say a little bit more what congruent means? And so with the which one doesn't belong, you get a lot of entry points with kids. You get a lot of entry points with high school students too, because many of them have not talked about these shapes since probably sixth grade, the last time we talked about quadrilaterals. And so again, you get a lot of prior knowledge out of it. You get students who can enter it. You can get of just about anything. And a student may not use the word vertex, but then they may say sitting on the pointy side, like what Mary had explained what vertex is. Um, so I think this is a great activity for any level of learning when it comes to geometry. I've used this exact one with high school kids too, and they really enjoyed it because they're like, oh, I know what to talk about. I know what to say during this activity. Um, and then we'll do another one. So I did a series of questions kind of like this. So do another question. So this is a convince me. What shape is this? So we'll take a little bit of time again. And I'd like for you to think about what shape is this, and then just give me a thumbs up in that you have an idea. If you are on a webinar, this is a great place to stop, pause the video, consider the question. And of course, I'm going to ask you what evidence supports your naming. Great. I'm going to type again. So just throw out some names. What would you name? How would you name the shape? Anybody? How would you name the shape?
Quadrilateral.
Anybody else?
I see Barb in the chat said it's a square, it's a rhombus. Jody said equal sides, 4 right angles. Sarah said it's a trapezoid. At least one of the opposite sides appear parallel. Not sure. Becca and Barb say it's a parallelogram. Mike says it's a trapezoid with inclusive definition.
Oh, Mike.
Ooh, Beth says it's a closed shape. It's a polygon.
All right, would anybody like to defend any of these names? How do you know? How did you know to name that? Or maybe you have a different name and you want to defend yours instead. Oops.
So Sarah said it's a preview of the Math Standards glossary coming out in the 2022 Math Standards. And that trapezoids can have exactly one pair of parallel sides or at least one pair of parallel sides. So that's something we can expect in the 2022 standards or look for.
Oh, thanks, Sarah. Okay, so we'll come out of this thinking mode. What do you think our students are using to come up with these names? Like, why would they say quadrilateral? Like, what's the evidence to say quadrilateral?
There is 4 sides and a
Right.
shape with 4 sides, so I can tell that.
Thanks, Sarah. What about square? That's because that's very specific. Why would a student say square?
It would be because it looks like it has 4 congruent sides and 4 right angles, but there's no markings to say that.
So then why would a student not say square? They would maybe say rhombus, or nobody said this, but I think some students would say this diamond. My students they probably won't use the word rhombus, but they use the word diamond because it is like what we said the other side, right there. It's tilted, so it's on its corner and its vertex. So some of my students would say diamond.
Yeah, I put in the chat too. They might also say kites just because the way it's positioned.
Mm-hmm. Yeah, because
Mhm.
typically we see kites like that too. Yeah. Um, Again, just thinking about this activity, right? What were all the prior knowledges or all the things that we could get out of our students? My high school students really love this activity too, because again, they could all enter it. It also helped remind them, like, oh yeah, I've heard of rhombus before because somebody else said it. Or somebody said polygon, and like everyone else, like, what is a polygon? It has nothing to do with 4 sides, right? But we know polygons is just general shape that has straight sides. And then the word parallelogram comes out, and then again, it just triggers a lot of like knowledge out of my students, and then they're able to describe things. They're able to tell me the difference between the square and the rhombus, or somebody else is able to do it for them, and they're not waiting for me to tell them what to do. Um, we won't do this one because I don't know if we have too much time, but then I do it by third. So I do all these kind of right in a row, right? Just getting students to think about how to justify um, how they're naming shapes or what attributes and characteristics they're using. So the question is, what is a rectopentagon and how do you know? Um, what I really like about this is because rectopentagon is kind of a made up shape, or did we just give it a real name now? And then examples and non-examples, right? What is and what isn't. Great way to look at geometry figures and shapes and get students to think about what are the things that make something something in geometry. And then this is where all of our high school students get to, right? Writing proofs. I always start with paragraph proofs. I never start with 2-column proofs with my students. I start with paragraph proof because they all know how to defend. They all know how to uh, put all their thoughts into like a paragraph, right? And then I always start with this question, what definition or facts do you know? So when they're looking at this, the word isosceles triangle shows up. They know things about it. They know about all the markings, like Sandy, I think that's what you said, like before. You're like, it kind of looks like a square, but we're not sure without markings. Well, all the markings in this figure also tells us so much about how to prove this an isosceles triangle. Um, And again, our students can put all that together, whether it's in a cohesive or concise way. They know how to make the argument because we just did it with the which one does it belong, the convince me of what shape it is, and the given a definition for what is a rectopentagon, right? So they did all that work already to get themselves here. I know our elementary middle school students aren't doing like formal proofs like this, but they are still constantly doing proofs, right? They're talking about what's the difference between a rectangle and a triangle, or all the different triangles there are, or the quadrilaterals. And so this is just more formal, but we're all been doing proofs the whole time before we get to our high school geometry.
Shelby said in the chat about her being able to see her students saying, we can't decide what it is without a coordinate grid.
Yeah. I like that too, because I actually did have one step in between that I had to cut out was I put this shape on a coordinate grid.
Mm-hmm.
And I said, okay, now let's prove actually what it is. But this last time I decided to skip it and just kind of do some of the talking and some of the proof thinking already before we got here. Mm-hmm. So what is this geometry strand?
Are you ready to click a lot, May?
Yes.
So the geometry strand in the 2022 standards is part of strand 2, spatial relations. And in that description of the strand, of those 3 strands, students will actively make sense of relationships between and within geometric figures. They're going to generalize statements about the figures and, so important, develop arguments about these relationships. Nowhere does it say anything about memorizing formulas or naming shapes. Building all of these skills listed here are helpful to approach the standards. Like if you're going to just name shapes and memorize formulas, but that's not enough to meet those standards.
So on this, I know we haven't done measurement yet as a webinar, but when we were in Duluth, when we did this the first time, measurement came right before us. And so we did a lot of comparative work, right? Like geometry is about analyzing the characteristics. And then measurement, the reason why we made 2 separate things is measurement's its own thing. We're using tools, we're using things. And I like the part that says in various culture, like how we measure really depends on your experience, really depends on the context you're in, because we are one of the few countries that uses feet, inches, miles, right? Everyone else is using centimeters, meters. And so even then, like our own American culture determines how we measure things. Or if you talk to my grandma, right? She's not using a ruler. She's using her hands. She's using her fists. She's using her feet to make measurements about things. Or this is kind of, I don't know if Sarah, I don't think I've ever told you this, but when I was a kid, how did my mom know that a pair of pants fit me? I don't know why she did this, but it was always true. She put the length of around your neck. Yes. And I'm like, how does that work? Right? Again, it's a measuring tool. So just kind of comparing these two, but we know that in elementary, some of these kind of overlap each other, right? When kids talk about squares, we talk about measurements, right? All the sides are the same. When we talk about equilateral triangle versus a scalene triangle, right? Measurements. So these two standards kind of overlap a little bit more in elementary and middle school, or they're kind of like one after another. Because I know when I teach 7th graders and we talk about circles, we talk about what's the definition of a circle, what is a circle, what's not a circle, and then we automatically jump into circumference and area. Right? There's not a lot of in between space when it comes to characteristics and measuring circles or measuring cylinders. Right? That kind of just comes right after each other. In high school, they get to be a little bit more separated, where I'd like to think of high school geometry as like the pursuit of truths, because they bring in all of these things they assume to be true, right? They assume all squares are equal sides, all squares have right angles. But then in high school, we're like, okay, now how do you know that's the truth? Or then we get a little bit more complicated with all of our similar triangles with SS and AAA and all of those theorems and axioms that prove what we know from elementary. So it just kind of starts to separate themselves a little bit more. We're not doing one after another or intermixing the two. This morning, I actually just went in. There's almost double the number of geometry benchmarks compared to the number of measurement benchmarks in high school. So you can see kind of that flip in what's the focus and what we're doing with the characteristics, the attributes of geometric figures instead. So, like I said, geometry is a lot of analyzing what you did and the activities that we did. That's all you did was analyze. None of you took out a ruler. Yes, we want to put it on a coordinate plane, but that's kind of like the next step. Like that's like the how to make argument justification, visualization. Like that's what's going to support us in knowing that that shape is a rectangle or a square or a rhombus. And we use attributes to make those things happen, and we use measurements to help us on that. And then the comparing and modeling, that comes up really early on in elementary now too, because I know like in the 2007, like it was a lot of like name, classify, but you're gonna start to see some of that change and say that are gonna justify, they're gonna compare, talk about relationships between. So just a lot more about communicating ideas and why things are the way they are.
Right. So geometry, as you can see in the lower left, that's the 2007 standards and kind of how they were chunked as far as strands and benchmark groupings. So geometry used to be the third strand of the four strands. Often got pushed to the end of curriculums and the school year, or you ran out of time and it got skipped entirely. I know I've run into that situation as a teacher. With the 2022 standards, it's now the second of three strands, and it's the fourth standard out of the seven. So kind of in the middle. We wanted to be able to have students develop geometry throughout the year, especially in K-5, not just like the geometry unit. And there is at least one benchmark in each grade supporting a progression of learning in geometry. And we'll talk a little bit more about that in a second.
And also when Sarah and I were putting this together, we were like, what is the difference between shapes and Euclidean geometry and reasoning, right? Because like
yes,
2007.
It was listed that way in 2007.
Yeah. So it's interesting that like we made a separation, even though we also do talk about shapes in like seventh grade, or Euclidean geometry is like the 2D stuff, right?
Mm-hmm. I know in the committee in May, you can correct me if I'm wrong, but you use the Van Heel levels, right?
Yeah, we did use the Van Heel levels to help us decide on the learning progression of geometry because we saw there were gaps in 2007, and we're like, how do we close these gaps? How do we make sure students are carrying their knowledge from year to year and not making a big jump, right? Because like right now, many of our students talk about geometry in depth in sixth grade, and that's really the last time. And then they move on to talk about circles, and then we want to talk about Pythagorean theorem, and then if you're in the traditional high school track, you're not talking about geometry again until 10th grade, right? And so it's like, how did we string this a little bit better for students? And the Van Heel is what really supported us in writing these benchmarks.
Yeah, so we'll take a look at those. This is from Enrich, if you haven't been there, great resource. But the progression of learning in this model starts out with the level 0. And that's where students can visualize, they can name shapes, but they can't really say why something is a certain shape. So it just looks like it. Somebody said in the Convince Me, it just looks like a square, right? An ice cream cone is a triangle because it looks like a triangle. Then we get into level 1, which is more analysis and description and noticing properties, like a square is a square because it has the same length sides, but they're not going to likely connect it to a rectangle without some further explanation. Then we get into level 2, informal deduction. So now we're starting to use properties to justify thinking about shapes, and we get into informal proving, and that's going to be like 6th, 7th grade. And then moving on to level 3 is more of a formal deduction. That's 8th grade, high school, beyond. At this level, they can give deductive geometric proofs. They're able to differentiate between necessary and sufficient conditions. They can identify which properties are implied by other properties. They understand the role of definitions, theorems, axioms, proofs. And then we get into level 4, which is like super high rigor, high school or beyond. Then students understand the way mathematical systems are established. and they're able to use all types of proofs. They can comprehend Euclidean and non-Euclidean geometry, and they're able to describe how adding or removing something, an accepted truth, affects a given system. And then 3 things that help learners progress through these levels: lots of visuals. Never skimp on the visuals. Let or require students to draw what they're thinking in that concrete representational abstract work. Don't skip the representation. And then this is not, and have students explain their thinking. Super important. Like we just showed some examples of how students can justify and prove their thoughts. And that's going to build as their skills go. And last, it's not a linear progression. They're going to spend a lot of time at levels 1, 2, and 3, especially 2 and 3, solidifying those justifications before they can get to those higher levels. So,
yeah, a lot of our high schoolers need those levels 2s and 3s still, right? We can't just jump them to just 3, but you got to bounce back to 2. Or you can go up to a little bit 4, but they're living here for a long time. And part of it is brain development, part of it is we are still facing some of our students who were gone during those like formative years of geometry in 2nd grade, 3rd grade, 4th grade during COVID. Like that's like our incoming 8th grade class, right? They were, I don't know how many of them touched a ruler because that's 2nd grade, and that was when they were, right? So just all of this, and I think like with any of our standards, the more concrete we can make it for them, the better they're going to get to those higher level thinking. So
Shelby asked, are we shooting to get kids to level 4 most of the time or just to level 3?
I would say level 4 is, I don't know if I did any of it till college.
Yeah.
And
Sarah Vanderis said only up to level 3 is assessed on the MCA.
Yeah.
But level 4 expected to be assessed in classroom assessments.
Mm-hmm. Yeah, because like non-Euclidean, I didn't know there was such a thing of non-Euclidean until college, But definitely like adding and removing axioms and truths, right? We do that a lot, just in a non-formal way. We don't think of them as axioms.
Mm-hmm.
So then what has changed? A lot of the things that we worked on as a committee was just making things clearer. Like we went through it all because it was a review committee versus a rewrite committee. We went through all of the benchmarks and really saw that like our benchmarks just didn't really say a whole lot about what students should know. We did a lot of like understand, show, but it wasn't like explain or justify. And so we did a lot of that, and especially in geometry. And that's why I think as a geometry standard, it got bigger. I know like our goal wasn't to get bigger, but it got bigger because we were like, okay, it needs to have the depth. It needs to have the rigor that we want our students to leave with. And so like we have a couple examples here, right? The 1st grade, they would create a composite, decompose composite shapes versus just compare and decompose. So just adding more things to it. Like a lot of teachers were doing it, but sometimes when it's not written there in more precise language, teachers missed it, especially if it's like the topic of geometry where a lot of teachers, again, skipped it or fill it in at the end. Like even me as a 7th grade teacher, right? Like how do I fit in my geometry parts into the school year? And like Sarah already said, there's going to be a glossary coming out, which is really helpful. It doesn't describe everything, it doesn't give us definitions to everything, but it will support a lot with being clear and more precise. And then honing in on definitions based on their attributes, right? A great example is 4th grade, given the relationship among the sides and angles. We're not just looking at them and knowing, oh, it's a scalene triangle, it's an obtuse triangle, it's a acute triangle. But what makes an obtuse triangle? How does it compare to the other angles or compare triangles to triangles? And then we talked about already, like flattening the curve of learning, right? Some of the jumps they felt really, really big. And so we gave 4th grade some stuff to support 5th grade learning. We gave 6th graders some things to support something 8th grade learning, just to support some of that and stretch out the learning versus making a big jump. And then a big change is 4th grade. We've removed those transformation words like translation, reflection, rotation. So as a seventh grade teacher, I kind of always expected my kids to come in knowing those words already, or at least the like move, turn, mirror, like those versions of those transformation words. But they're being removed. It just didn't feel right to keep it in fourth grade because it wasn't connecting to everything else. So they're removed, and I think seventh grade is probably one of the first times I've formally taught it. But then we also added things in third grade. Right? We pulled something from fourth grade and moved it to third grade to support some of the learning there. And then what's really, really new and what we felt Common Core did a really good job at, and we did not in Minnesota, was orientation and relative position or location of the figure. I think we talked about it a little bit in the 2007, but it just wasn't clear, right? Once I and I could see that in my own students. I turned something on its side, and my students were like, "What shape is that now?" Or I just didn't have it next to something else. And they were just, there was a lot of confusion about orientation or relative position. And then Common Core did a really good job at it. So we kind of took a lot of that from them and said, our students need this. Because again, these are some of the real life applications of what's going to happen. And so that came there. So K
With
through,
that, there'll be less unteaching in the later grades. So
yes.
it'll be more consistent across the grades.
Mm-hmm. And then just the understanding that doesn't change size, right? And then seventh grade in high school is when we do start changing size with similar figures. Again, something that Common Core did really well that we just was like, we need to take this from them and just do a better job at it in Minnesota. And then, of course, there's this high school, like literally it's just this one benchmark. It says apply concept of density based on area and volume in modeling contextual situations. I read that over and over again. I'm like, I just need to see this. And this is straight up from Common Core too. And so they have examples of this in Common Core to support in the learning of the high school side of it. And most of this too, a lot of our resources do point towards Common Core. I'd say we're closer. We're not Common Core, but we're just closer to them for sure. And this is just the key. Like, how do we support our students? And I think these are things that we've done in the past, just have not been very good at it because it wasn't explicit in our standards.
All right. So what do we do about this? As your district or school or even yourself, consider implementing the new standards over the next 2 to 3 years. The full implementation will be the 27-28 school year. That's when the MCA4 will be testing using the 2022 standards. So getting ready for that, looking at your scope and sequence, when are the geometry concepts taught? Evaluate what prior knowledge students need in order to do those concepts. If they didn't get it in the earlier years because you're still working on 2007 standards, what do you need to do to connect those ideas? And how can you work that in without stopping everything and doing something in addition to all the standards you have to fill in? This is things like doing those number talks that are quick that May showed you. I always think about kindergarten teachers, and they're really good at integrating things, like always taking that moment to throw in something. So doing a shape talk to start the class, and then doing that shape talk often enough through the year so that it's integrated into their brain, and you don't need to do necessarily a big geometry unit. So spending that time talking about it and connecting it to other ideas. So thinking about how we can connect geometry to other math concepts, where does it show up in other areas for K-5 students? It's a little easier for an elementary teacher since they're teaching everything generally to the same students. But how does Anchor Standard 3 measurement overlap with geometry? And I know the measurement one's coming up. I think that'll be helpful. And just looking out for other connections and really highlighting them for students in science, in other areas.
And then there's that bullet about, does geometry need to be a full high school course?
Oh, yeah.
Right. There's just been conversations around it a lot because there's not as many geometry standards as there are algebra standards in high school, or statistics now, right? That's the other.
Yeah.
And so, like, St. Paul Public School, our our answer, but not really an answer to it, was to move to integrated math. So if you've been teaching math long enough, especially high school math, you know that integrated math has come and gone in Minnesota, and St. Paul decided to bring it back. And so integrated math is they do 3 years of math where they do geometry, statistics, and algebra all 3 years. Um, and so that's something to think about. Or I talked to a friend of mine, Jessica Strom, about, what to do about all the statistics and geometry. And we talked about making that into like a common course too. Just different things, like how do you split up? Because high school, we're not told how to split up those standards. It's just a grade band over 3 years.
Mm-hmm.
So
I
something
will say, I'm going to interrupt you and just say, I would recommend checking out MCTM's High School Task Force. They have a like 30-page document out on recommendations for pathways for high school with the new standards.
Mhm. Yeah. So high school can get kind of tricky, but again, no one's like the state did not determine. We did not determine as a committee to say these are what ninth graders, 10th graders, 11th graders are doing. You just have a 3-year grade band.
Yeah. Local control state. So some examples may should you convince me. Another one is would you rather, which is kind of amazing because you can do, there's no wrong answer, but you just have to focus on the justification. Which one doesn't belong? Same but different is another one, especially for reaching back to things, to the underlying knowledge that students need to make sure they have before you teach something new, and making that connection between those two things. So if I show you something that you saw in 5th grade and compare it to something similar related in 6th grade, you could talk about what's the same and what's different about it. May did a great job of showing how you compare plain language with mathematical language. So she said the square has 4 vertices or corners, using that vertices word and corners.
I learned a lot from Sarah Vanderwerf, actually.
Mm-hmm.
Like, I feel like you do this as a teacher and then you don't know it that you're doing it, but Sarah really helped me put it together that like this is something a lot of us do all the time already, and just continue to do it. It's good for our EL students, so that's good for all of our students. And I think that's what a lot of teachers will say is geometry's vocabulary is what catches our students, right? They know what they're talking about. They know their square has 4 corners, but they forgot the word vertices.
Mm-hmm.
Bases, they know that's the flat part. So how do we support our students? Parrot the plain language all the time. And again, you naturally do it all the time now, but again, Sarah Vanderwerf gave me words on how to describe what I'm doing.
I can still be smart, even if I don't quite have the language.
Mm-hmm.
Because someone will help me out.
Mm-hmm.
All right. So my jam is elementary math. And we were thinking about what are some examples of what we can do to really give ideas for teachers. Kindergarten through 2nd grade, it's all about describing in so many ways. So looking for shapes, explaining why a shape is what you think it is. Really moving, like once students know shape names and can identify them in their space, starting to work on attributes and really why is a square a square? Why is a rectangle a rectangle?
And myself, I have a 4-year-old and a 2-year-old. So even when we read books that are not math book, we still talk about the shapes in there,
Mm-hmm.
right? And so again, K1-2 teachers are so good about this. And I only got this when I started to have my own children. Like, you can use any book and turn it into a math book. Or any poem turn into a math poem.
Mm-hmm. Yep. Here's an example of like a 3rd or 4th grade idea. So in this, thinking about, you have a measurement problem, because that's what this is. The perimeter of a regular pentagon is 40 centimeters, but there are attributes of shapes that you need to understand in order to solve this problem. So there's that connection. So what are the attributes of a regular pentagon? It's going to be 5 equal sides. And then I get to practice my multiplication or my division skills in order to solve that problem. So really nice integrated problem.
7th and 8th grade, right? You can start to just replace some of those numbers with variables, and you get to work on all the attributes along with measurements, along with algebra skills. I know like a problem like this would really be hard for my 8th graders, but they need it, right? They need all of it. They need to know perimeter. They need to know that's different than area. Many of them come in already know what a rectangle is, so they could tell me what the opposite side lengths are. But then again, it's all of the things that make us something more rigorous, but also spiral some of the review for our students and bring in some of the things they know. Right? Again, my students who struggle to solve this, they know what a rectangle is, so I have a win there for them already. And then they're more willing to jump into this problem because they have a win. But yeah, it's just kind of like, how do we intersect this? And we're doing this already, or our textbooks do this for us already. We're just pulling it all out and saying, hey, this is where it is. And then high school is a little different, right? It's not about like integrating, but it's also just asking our students, like, how do you define similar? How do you do proportional reasoning? Like, this is a hard problem for our high school students, but it is also a problem they've seen in middle school before, too. And again, it's just so long ago for many of them, right? They do similar figures in 7th grade with scale factors, and they don't do it again until typically 10th grade. So it's just a long time in between. And then we also start to talk about the theorems and theorems and axioms that make these true, right? You don't need measurements anymore to know that we have similar triangles through AA or SAS or SSS similarity. Like, to just kind of like the crashing of the two, but how do we support our students in knowing this? How do we scaffold it for them?
Right. Well, before we get into this resources, are there any questions? I know there's a lot to this, and we tried to do a quick run through. You can either unmute or put in chat things we forgot.
I know in here Shelby said she's done a ton with the density topics with her high school students. So if you are teaching high school geometry, jot her email down, shoot her an email, especially if you're like me, you're like, what is this about? Like I haven't taught high school geometry in a very long time. So right now I'm like, oh, who cares? But if you are like Shelby, you're in it, shoot her an email for sure. She's probably someone you want to talk to. Um, for the people online, oh, how do we do this, Sarah?
You mean with the
Oh, for the
resources?
webinar, yeah. How do we?
But with this, I'm pretty sure Sarah's going to put this in the resources if she hasn't already. So we have within this slideshow, can you click on one of the, so let's click on general at the link up there. I think the picture works too. So we have some links to information. Always love Polypad, especially for geometry. It's an awesome resource. Talking about the Common Core progression. We talked about the Van Heel levels. Math on a Stick has so much geometry if you want to come visit us at the state fair, or if you want to volunteer. We're still looking for volunteers. Shadiest spot at the fair. And then we also have a progression video about the 2007 standards. It's fairly old, but it still helps you think about where one concept leads to another. And then if you click on the back button, May, take us back there. We've got one specifically for elementary and then another one specifically for high school or secondary.
Yeah, with secondary, yeah, we did a lot of illustrative just because that's an open source curriculum. I actually really like the curriculum. It's not the one my district uses, but I really like them a lot. And then, like we said, a lot of our standards are and benchmarks are matching Common Core now. And so if you have an older curriculum that you're using or your school's still going through a curriculum development, like curriculum adoption process, and you need something, this is a great place to come for it. The big ideas document, we leaned on that heavily for writing our standards and benchmarks. So that's a great one to kind of look at too. And then anything you need, like I said, like I helped St. Paul with the rollout of integrated math, not this past school year, but the year before that. And so if you are like, what does integrated mean? How does it look like? How did you guys divide it up? Let me know. The curriculum we ended up going with is Savis Envision, and they do have an integrated system that we are using. This will be year 3, so our students are finally we have phased out the traditional algebra, geometry, algebra route for students who have passed, and so everybody's in integrated system now. The only students left in the AGA model is because they've lost credit along the way. But other than that, all our teachers are teaching algebra, geometry, statistics every year. So if you've never taught geometry, which I've met quite a few in St. Paul, they've never taught geometry before. That made them a little bit nervous to have to teach geometry because like, oh, how do I do proofs? How do I do this? How do I do that? And algebra just came to them.
Along that line, I would highly recommend if you have questions about this or just want thought partners, two things. The Minnesota Math Leaders, which is now there's 3 meetings a month, well, like an early morning shortened one, a school day one, and then an evening one. And that's that's the topic for a lot of people there is let's talk about how we're going to handle the new high school math standards. The other thing is I know Kim's on here. She's my partner at Compass, and we at the Compass team are available to help any public school for no charge. If you just want a thought partner, more depth, give us a ring. My email will be up in the slideshow.
And every area has their own compass, but if you don't know, you just reach out to Sarah and Kim or Sarah.
Yeah, we'll get you to the people you need.
She's the right person. But yeah, like Sarah, you are Twin Cities essentially.
Yeah, we're like the 7-county metro area. So,
but every part, yeah, Mary's it.
So what's next? 3 key takeaways we were hoping you would get from this. We can support online teachers too, Shelby. We have. Okay, so takeaway number 1, the K-12 geometry progression, that you understand those levels and that the connection between concepts, where they lie and how they connect. The shifts in the standards, where we approach them, where they're located, and just how we thought about them, what you can expect. And then support for implementing ideas, and if you need further support, where you can go. And then thinking about what you can do following this session. Number 1 is thinking about which of the key takeaways do you need to do more learning around. Maybe you need to explore the benchmarks and strands. Maybe you need to look into what your curriculum says. What are your things that you need to do? The next thing is who, because none of us can do this work by ourselves. I mean, some people still do, and they're amazing at it, but it's so much better with partners. Who can you share this information with at your district or in your school, so that you are not all by yourself? And then when you're going to do it. Maybe you're going to do it right now because you're in like back to school mode, but maybe you're not ready for that. Set yourself a calendar alert on your phone or something, and let yourself know, hey, here's the link, come back to it when you have a little more brain space or time, or you're not on summer vacation. So,
and we have a little bit of time yet before we must implement this.
Mm-hmm.
Like if you're like me, last year was my first year back in the classroom after a couple of years out, and I'm like, I may have been on the committee, but I'm like, I'm not ready to think about how to implement any of this in my classroom. And so after a year under my belt, I'm like, okay, I think I'm ready to look at 7th grade, just 7th grade, and so it's just, we have time, but also don't put it off forever.
All right. This calendar is amazing. If you want to know all about the Minnesota Math Leaders, any other trainings, webinar stuff that's going on, this is the place you can find it. And the resources for all of these sessions.
Yeah, everyone should have their Google Docs and slides from the spring, because we all did all these during the Duluth Spring Conference. And so don't feel like when you go there that they're all in progress. They should be there already, but also definitely attend the webinars if you were not in Duluth, or in Duluth, didn't want to go to all of them because it was a lot and you miss out on other sessions.
And they'll be linked there once this is uploaded, it'll be linked there. The other ones are linked there. So yeah. And so this is my information and May's information. Don't hesitate to reach out. We love talking about math and all this stuff. The little light bulb there, our Compass group has some pathways, year-long learning opportunities that you can sign up for if you have questions about that. That works too. Thanks, Shelby. All right.
And anyone's welcome to my classroom. I've had lots of visitors this past year. Even Sarah's come to my classroom. So yeah, you're welcome to come and chat, or you're welcome to just come and see.
It's so cool.
I teach some this year. I'll be doing 7th and 8th graders, and so yeah, come anytime. I have great space. This is the first time ever in my career that I have great space. So I think it's
All right.
is there anything anyone would like to say? I know, like, thank you, Shelby, for like giving yourself like some ideas out there and sharing. Becca, I like what you said. So you like really using the ideas of geometry talks. You're gonna share with your school. I was gonna bounce the idea off your dad. I assume your dad's a math teacher too. And then Sarah Vandervoort said she'll be releasing a new updated calendar tomorrow with some of the one-stop shop of everything for math.
Will that be the same links, Sarah?
Yeah, you should have the one-stop shop link.
Yeah.
It's, you know, I link to it everywhere. Everything is on there. I also put in the chat a link, and maybe we can link it in your folder or wherever you have some links. I updated that video that you recommended to include the 2022 standards, not just the 2007 standards. So it's a great video for both sets of standards, and it's a great thing to do to get ready and also simultaneously teach the current standards.